Welcome back. This is Mrs. Rubright with Advanced Algebra 1 Honors, and today's lesson is 4.1, Identify Linear Functions. Alright, so we have discrete versus continuous functions. So once again, discrete functions are when there's those independent points, right? So if you're dealing with people, you can't have part of a person. If you are dealing with purchasing items where you can only buy, one whole item. You can't buy part of an item. Where continuous is going to be more like when you go to Winn-Dixie and you're buying candy or you're buying coffee and there's all those increments in between. You could buy 2.46 pounds of coffee and then it has a specific price. So that's going to be, the continuous function is going to be when you have that straight line, like that linear function, or it could be parabolic. It could be anything. It's going to be connected, okay? Where discrete is going to be like just specific points. All right. So analyzing a discrete real-world function. You buy a printer for $80 and then pay $15 for the ink cartridge that you use. A function relating the cost, C in dollars, of operating the printer to the number of cartridges used is, which is N, is going to be C of N equals 15N plus 80. So it's $80 to buy the printer plus $15 per ink cartridge is going to be the total cost accrued in using that printer. So for A, complete the table to represent the total cost of 0 to 4 cartridges. So when you have purchased 0 cartridges, you still bought the printer, so it's still going to be $80, right? Because 0 times 15 is 0 plus 80 is 80. So your total cost is still the cost of the printer. If you buy 1 cartridge at $15 plus the $80 printer, you are at $95. If you buy 2 cartridges, you have $15 more, right? So that's going to be $110. Then you're going to have $125 and $140 when you're plugging in these numbers right here into your equation, into your formula. All right, so then they also want you to graph the function from part A and specify the scale that you will use. All right, so we have our cost in dollars. All right, our cost in dollars. And then we have our cartridges. Put that T before, I put the R before the T on accident. Cartridges. Okay. So the number of cartridges. So we could have 1 cartridge, 2, 3, or 4, or we could actually have 0, right? And then for dollars, we have all the way up to $140. So let's think. So if we went by tens, we'd have 10, 20, 30, 40, 50, 60, not going to fit. How about 20s? 20, 40, 60, 80, 100, 120, 140. That'll fit. So let's go by 20s. All right, so at 0, we have 80. At 1, we have 95. At 2, we have 110. At 3, we have 125. At 4, we have 140. Looks pretty linear to me. What is the initial value of the cost function? So the initial value of the cost function is going to be $80. The cost of the printer. What does it represent? The cost of the printer. What number of cartridges responds to the initial cost? 0 cartridges. Compare the differences in cost with each unit increase in the number of cartridges purchased. So it's going up by how much each time? So this is an arithmetic function, right? It has a common difference of 15. So it's going up $15 per unit, right? It's a $15 per unit increase. Which is the cost per additional ink cartridge. Identify the domain and the range of the function using set notation. So your domain is your x value. So this is always going to be your y, this is always going to be your x, right? So your domain is your x values. So that's 0, 1, 2. So you have 0, 1, 2, 3, or 4 ink cartridges. And then your range is your y values. That's going to be your cost based on how many ink cartridges you've purchased. So for that, you're either going to have 80, 95, 110, 125, or 140. And if they buy more ink cartridges, you can put ... on these, right? Because that just means that, and so on. So if you bought 5 cartridges, 6 cartridges, 7 cartridges, 8 cartridges, and so on. Describe the pattern formed by the points in the graph. So it's definitely linear. It goes in a straight line, right? And it slants up from left to right, so it's a positive linear correlation, right? So it's the points lie in a straight line that slants up from left to right. It's really basically like a positive linear correlation. How do your answers change if the price of the printer is $90? So, the cost of 0 ink cartridges would be 90. Then each ink cartridge is 15 more. So you're going to basically have your range will become 90, 105, 120, 135, 150, and so on. Right? Everything just goes up $10 for the range. Your domain stays the same. Your range increases by 10 on everything. Right? Same domain. Range, everything increases by 10 since the cost of the printer was $10 more. The functions whose output values have a common difference of each unit increase in the input values is a linear function. So if they have a common difference, right, it's going to be linear. It has the same slope, the same rise over run. A linear function can be represented by f of x equals mx plus b. This is the same thing as y equals mx plus b. M is your slope. B is your y-intercept. That's the value when x is 0. Where m and b are constants, the graph of a linear function forms a straight line. When a linear function is discrete, that's going to be just independent dots, right? The graph consists of isolated points along a straight line. If the discrete linear function has inputs that are a set of equally spaced integers, then the outputs form an arithmetic sequence. All right, so give 3 reasons why the cost function in the Explorer is linear. So why is it linear? Well, didn't it have a common difference of $15 per ink cartridge? So it was like rise 15, run 1, rise 15, run 1, rise 15, run 1. It had a slope of 15, right? So there is a common difference of $15 per unit increase in the input The function has the form f of x equals mx plus b. The graph is a series of points along, I did not talk to you Siri, I said series, not Siri, sorry. Okay, my phone is deciding to listen. Along a line. What are m and b, and what do they represent for the cost function? All right, so m is your slope. It is $15 per cartridge. B is your y-intercept, your initial cost of the printer, which is $80, right? When n equals 0, right? When you're buying no ink cartridges. Avocados cost $1.50 each. Green beans cost $1.50 per pound. The total cost of A avocados is C of A equals $1.50 per avocado, 1.5A. Per means multiply, right guys? And the total cost of G pounds of green beans is cost of green beans equals 1.5, $1.50 times the number of green beans, right? The number of pounds of green beans. Complete the tables to find a few values. All right, so cost of avocados. So if we're buying 0 avocados, it's $0. If we're buying one avocado at $1.50 each is going to be $1.50. 2 avocados at $1.50 each is $3. 3 avocados at $1.50 each is $4.50. So 1, 1.5, 2, 3, 3, 4.50, 4.5, right? Green beans. 0 green beans, $0. 1 pound of green beans, 2 pounds of green beans, 3 pounds of green beans. So 1 pound at $1.50 a pound is $1.50. 2 pounds at $1.50 a pound is $3. 3 pounds at $1.50 a pound is $4.50. So we can notice that we actually have the exact same points, right? We have the exact same cost because it's $1.50 a pound versus $1.50 an item. So what is a reasonable domain for C of A and C of G? Well, they're both going to be the same, right? So, sort of, kind of, almost. Let's see why it's an almost, kind of, sort of. So C of A, your cost of avocados, your domain is going to be what? You can only have whole avocados, right? They're not going to let you buy part of an avocado. You can't buy a half an avocado. So, the set of whole numbers. You can only buy whole numbers of avocados. You can't buy part of an avocado. Okay. How about C of G? Your domain is going to be what? The set of all real numbers. Because you can buy part of a pound, right? You can buy 1.1 pounds, 1.25 pounds, and so on. You can buy part of a pound. Okay? And it's all real numbers where G is greater than or equal to 0, right? You can't buy negative pounds, right? So it has to be greater than or equal to 0 because we're purchasing nothing or we're purchasing something, a positive amount of green beans. We can't have negative weight, all right? Graph the two cost functions for all appropriate domain values for the given scales below. All right, so We're going to put some labels on here. So we have our cost in dollars. That's going to be on both of them. Then we're going to have our avocados and our green beans. Our green beans are in pounds. Okay. So going back to our points, we had 0, 0. We had 1 for $1.50, right? Two was $3, 3 was $4.50. Okay? And we are going to continue on this. So 4 would be how much? $6. And then $1.50 more. Right? Same thing for green beans. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. So once again, same graph. So we have 1.5. We have 3. We have 4.5. We have 6. We have 7.5. Now the difference is, with avocados, you can only buy whole avocados. With green beans, you have all these measurements in between because they weigh it, and you pay based on the total weight, right? So this is going to be continuous, and this is discrete. Continuous and discrete, okay? So, compare the graphs. How are they like? How are they different? So, they both have the same points, right? They both have the same points, but the avocados are discrete, where the green beans are continuous. So they include all the fractional costs and weights. Right? So it includes like more points than just the avocados. The avocados are only whole number domains and ranges, right? Where the green beans include all of those fractions, right? Like those parts of a pound. Describe the range for C of A and C of G. So for C of A, our range, our Y values. So for C of A, our Y values are 0, 1.5, 3, right? 0, 1.5, 3, 4.5, 6, 7.5, and so on, right? For our C of G, our range is going to be what? Y such that Y is greater than or equal to 0, right? It's continuous. Or all real numbers where G is greater than or equal to 0. Pretty much, right? How do the units of A and G imply that their graphs will be different? So, the units for A, number of avocados, implies that the domain is whole numbers. So fractional inputs when it makes sense. the units for G, pounds implies that the domain is non-negative, right? It can't be a negative number. Non-negative real numbers. So there are no gaps between input values. Right? All those fractions are included. That's why we connect the line. A function whose graph is unbroken is a continuous function. Tell which cost is continuous and which is discrete. So, green beans, C of G is continuous. C of A is discrete. Comparing functions given a table and a rule. The function f of x and g of x are linear. The initial value for the range of each function. Find the initial value for the range of each function. Okay, so f of x, the initial value. Then compare the functions. Okay, so the table gives the values of f of x. The domain of f of x is 4, 5, 6, and 7. Let the domain of the function g of x be 2x plus 3. Is going to be all real numbers, so then x would fall between 4 and 7, right? 4 to 7? Okay. The initial value is the output that is paired with the least input. All right, so the initial value, f of x, is f of 4, which gives you 8. The initial value of g of x is 4, and that input of 4 gives you an output of 11. The range of f of x is going to be 8, 10, 12, 14. Because g of x is continuous linear function, the range g of 4 is less than or equal to g of x, which is less than or equal to g of 7. Or when we plug in a 4, we get 11. When we plug in that 7, we get 17. So it's between 11 and 17. Right? When we plug in a 4, 8 plus 3 is 11. And when we plug in, that's what I'm doing. Sorry. 8 plus 3 is 11. And when we plugged in a 7, 14 plus 3, 17. That's where we're getting our numbers. We're plugging into the formula that they gave. Okay. So, how are the functions alike? How are they different? Consider the domains, the initial values, and the ranges. All right, so both functions are defined over a domain from 4 to 7, but the domain of f of x consists of whole numbers, while the domain of g of x consists of real numbers. The initial value occurs at the same input, which is 4, right, for both functions. But the initial value for g of x which is 11, is greater than the initial value for f of x, which is 8. The range of f of x is even whole numbers from 8 to 14, whereas the range of g of x is real numbers from 11 to 17. Find and compare the common differences per unit increase in the input values for the functions f of x and g of x in the example. Okay, so for f of x, all right, so let's look. This f of x is what? Plus 2, plus 2, plus 2. F of x has a common difference of 2. G of x has a common difference of what? Let's look. Where's our g of x? This one was up 2, up 2, up 2. G of x, if we're plugging in a 4, 5, 6, 7. So for 4 we got 11. For 7 we got 17. If we plugged in a 5, that'd be 10, 11, 12, 13. If we plugged in a 6, that'd be 12, 13, 14, 15. So these are going up 2 each time also. So it also has a common difference of 2. Okay, so they both have a common difference of 2. Can you tell that f of x and g of x in the example are linear? They are linear, right? They're going up 2 over 1, up 2 over 1. Yes, they both have a slope of 2. Okay? And I think that that is actually a great place to stop. So we are going to do our homework tonight on 181 and 182. So you guys only have 11 problems of homework tonight. I hope you guys enjoyed this lesson on 4.1, Identify Linear Functions. Have a great day. Like and subscribe.